Welcome everyone. Let's begin our lesson for today by looking at our learning goals and success criteria. First, what are we learning? We're learning how to compute exponential expressions on integers and fractions. We're learning how to perform basic exponential operations and recognize like terms, how to work with positive, negative, and fractional exponents on integers and variables, how to recognize patterns in linear functions and exponential functions, how to recognize the differences between linear functions and exponential functions, how to recognize patterns in the graphs of exponential functions, to determine how base values, coefficients, and constants will affect the graph of an exponential function, how to graph exponential functions, how to find function values for exponential growth functions, and how to find function values for exponential decay functions. How are we learning it? Through the population overload assignment. When can we use this? To calculate the amount of money in a savings account including interest, to calculate the amount of money owed on a loan including interest, to examine sales trends at work to determine how much growth is occurring within the company's sales, and to complete a variety of tasks through trial and error rather than having to be formally taught the procedures. How do we know we learned it? By getting a score of 4 on the population overload assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. After that, we'll complete the population overload assignment on Desmos. Once we've completed the assignment, we'll go back over our learning goals and success criteria again, and then you'll fill out your before you go. Your only homework is to complete any incomplete assignments that you may have. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the population overload assignment. Our assignment begins with the learning goals and success criteria. We'll go ahead and scroll down. There's a link here that takes us to the Desmos assignment. Go ahead and click on that link, and it will take us to a page that looks like this. We'll go ahead and click Start the Activity. The activity begins with our learning goals and success criteria. We'll go ahead and click Next. There's an introduction video for you to watch here. Now, the first question says the population of bacteria doubles every hour. The initial number of bacteria is 5. Answer the following questions to calculate the population of bacteria. So it says, write the equation that might be used to find the total population of bacteria after X number of hours. Well, we can see that we're doubling, so we're multiplying each time. So we know it's going to be an exponential function. We know that exponential functions are of the form y equals a times b to the x. So we're going to use x as our number of hours. Now, a always represents our starting amount, which in this case is 5. So we're going to change this to be 5. And b is always the number that we're multiplying by each time. Well, we can see that we're doubling, so that means we're multiplying by 2 each time. So b should be 2. So we should end up with an equation of y equals 5 times 2 to the x. Now, we're going to go ahead and plot these points. So the first one is at 1 hour. So at 1 hour, 2 to the first power is 2, times 5 is 10. So at hour 1, we're at 10. Then we're going to do it again for the next one. So 2 to the second power, because x would be 2. So 2 to the second power is 4, times 5 is 20. So at hour 2, we're at 20. And we should know that we're doubling each time. So this one's 20. So the next time we move, we should double 20, which is 40. And then again would be 80. And the next one would be 160, but that goes off the screen, so that's okay. This is good enough here. Then we're going to go ahead and click Next. Notice it imported our graph for us, and it says state the population of the bacteria after 1 hour. So how many bacteria? Well, we can see that according to our graph, there were 10. We're going to put 10 bacteria. What about after 4 hours? How many are there? After 5 hours, how many are there? And then they changed the scenario a little bit. It says, what if the average lifespan of bacteria is only 5 hours? Explain how this might affect the graph you created. So right now it's exponential, right? But if some of these start to die, what's that going to cause the graph to do? So you'll go ahead and answer that question. Then we'll go to the next one. We're given a graph here, and we're asked to answer these statements and decide whether they are true or false. For instance, the first one says the mouse population was decreasing between day 40 and day 80. Well, this is 20, 40, 60, 80, 100. So between 40 and 80 here is the graph going down. Well, we can see that it is going down, so that one is true. And so on. So you'll answer each of these. Then when you get to the end, there's a closing video for you to watch.
Oh, because all the animals in Jurassic Park are female. Oh. We've engineered them that way.
Blood temperature seems like a high 80s, maybe.
Whoop. 91.
Homeothermic? Mm-hmm. It holds that temperature? Yeah. That's incredible.
But, again, how do you know they're all female? Or does somebody go out in the park and pull up the dinosaurs' skirts?
We control their chromosomes. It's really not that difficult. All vertebrate embryos are inherently female anyway. They just require an extra hormone given at the right developmental stage to make them male. We simply deny them that.
Deny them that?
John, the kind of control you're attempting is, it's not possible. Listen, if there's one thing the history of evolution has taught us, it's that life will not be contained. Life breaks free, it expands to new territories, and it crashes through barriers painfully, maybe even dangerously, but, well, there it is. There it is.
You're implying that a group composed entirely of female animals will breed?
No, I'm simply saying that life, finds a way. Boy, do I hate being right all the time. Keep absolutely still. Suspicion is based on movement. Turn the light off. Turn the light off.
Turn the light off!
Once you've completed this assignment, you'll go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.